Greetings everyone, this is Non-Expert here back again with another video. Today we are going to be solving problem number 3 of the 30-day LeetCode challenge, and the problem which has been given to us is the maximum subarray problem. We've already solved this problem before in one of our previous videos, so if I'm going too fast for you, you can find a detailed explanation of the video in the link below. And if you try to solve this problem on your own, you can pause this video and check out the LeetCode link in the description. So let's just go through a problem statement really quickly. You've been given the integer array nums, and you need to find the contiguous subarray which has at least one number, which is the largest sum, and then return its sum. So you've been given a array over here. You need to find the maximum subcontiguous subarray. And over here, if you look at it, the output is 6, and the reason for that is because if you look at the selected subarray, that sort of forms the largest sum. So that's basically the entire ideology behind this thing. And they've been given a few follow-up questions that you want to solve this in O of n, and so on and so forth. So we're going to try to make this problem a little bit more difficult. We're going to assume that you can't use brute force approach, and you want to make sure that whatever nums, whatever argument that you're getting inside this function, that nums variable is immutable, so you can't really make changes to that, and you want to work around with that. So my ideology behind this thing would be just to use two variables, and you already know the name of the algorithm, which I'm going to be referring to. But if you don't, that doesn't really matter. The way we're going to be going about it is we're going to maintain two variables. The first variable is going to be the current maximum that we've got so far, with that we've encountered, and the maximum that we can formulate so far, and then do the comparisons accordingly. So we're going to start with the base condition, which is going to be, hey, if there's no nums which has been given to us, then we can't really do anything. And let's create two variables, just to say sum so far. I'm going to assign this nums 0, which is going to be the first number, and the current max as well. So let's do that. Let's do nums of 0. All we're going to do is we're going to do a simple iteration, and I don't really need to do range also. I can just do for nums of this thing, where I'm splicing out the list, and I'm just starting from the from the second element, since I already have the first element stored inside. And all I'm going to do is I'm going to update the sum so far with the maximum of sum so far plus the number that you have and the number. So this will handle the negatives for us, and the current maximum, which is going to be the current maximum and the sum so far, and basically return the current maximum, and that should basically be it. I'm assuming I'm not making any mistakes over here. You can see that it's running fine, and the solution has been accepted as well. Awesome. So the entire ideology behind this approach is just that you want to make sure that you contain two variables. The first variable is to contain what's the sum that you've encountered so far. That will also include and switch over whenever you have negative values. So if the sum so far is negative, and the number that you have, the next number that you have is positive, those things will get flipped over. And that's the entire approach for it. So that's basically it for today's video. I wanted to make this as short as possible so that you guys can have a look at it, and we've already solved this problem before. But yeah, if you did like this video, do give a like. If you didn't understand something, you can check out the link given in the description below, which has a more detailed and elaborate explanation of what's happening. And I hope everybody's staying safe. Um, and thank you so much for all your support. If you subscribed, you're awesome. We all know it. And have an awesome day. Thank you.